Right, so let's move on to the next subtopic, the perimeter of plane figures containing sector of circles. So lastly, we learned about how we get the perimeter of of the sectors, and now we're going to do some exercises that's basically, mixed with some other shapes as well. This is really good. It's a really good exercise for you to practice your perimeter and in-depth understanding of these. Uh, Yeah, so I'm not going to go through the examples because I believe uh, finding perimeter of these normal shapes, these normal figures have been done, I think, in grade 8, 9, 8 or 9, right? One of them. So basic. I'm just going to skip all the examples and just jump straight into the exercise, right? Uh, right. So in exercise 1.3, question number 1, we have been given two shapes and we have been asked to find the perimeter of each of the following plane figures, right? And an additional detail is given, that is O denotes the center of the circle of the sector in the figure. Okay, let's try solving this thing. So in our first figure, we can see uh, before that how do you find the perimeter is where you add all the outer lines, right? Basically the exterior part of the figure. So you have here 18 centimeter and 14 centimeter. So those are the only two data given. What we only have to find is the opposite side of this rectangle and the arc length. You see the arc length of this sector that's attached to this rectangle. Correct? Um, we already know that this part of the rectangle, it's already 18 as the opposite sides are equal in a triangle. Therefore, 18 and 18 on the other side. So now we have to focus on our the sector of the circle. Sorry, the arc. Okay, we have to find the arc length. So how do you find the arc length? What is the arc length formula, if anyone remembers, right? It is yeah, it's tan theta of 360 into 2 into 22 over 7 into radius. Now in this case, what's our radius? Since this side is 14, we know that in a triangle, in a rectangle, opposite sides are equal. That means this part is also 14, meaning the diameter of the sector is 14 centimeter. But we need radius. The radius means half of the diameter, which is 7, right? And what is our theta actually? Since it was a half sector, you can just erase this part and directly write what? Half. Okay. So we can cut 2, and then 7, 7. So we'll be only going with what? 22 centimeters. So 22 centimeter is the arc length of this part, right? It's the arc length of this sector. So at the end, what are we left with? So we basically have to add all the exterior parts. And that will be what? 18, 18, 14, and 22. Please make sure that you have to add the outer parts only. This has nothing to do with the perimeter, right? The definition of perimeter itself means adding the exterior borders of a figure, right? So what were the values we had? We had, so yeah, perimeter is equals to what? 14 plus 18 plus 18 and the length 22. Right? So what is the answer? Right, so at the end, the answer is what? 22 centimeters. Make sure you leave your answers in centimeter. There are some students, they don't write the centimeter and they will lose a lot of marks in the exam and in O levels as well. So please make sure you write your centimeters. Right, in the next figure, we have a triangle attached with a sector at the bottom, a half sector, right, a half circle. So yeah, let's see how can we solve it. So before doing anything, you have to make sure uh, to understand the data that's given, right? So can I zoom? So we can see in this triangle, it's an, what triangle is it? It's an isosceles triangle. Why? Because there are two sides equal. They gave the two sides are equal. That means if this side is 4 centimeters, then this side is also 4 centimeters. And then we have the baseline as 7 centimeter, or if you take in the sector's perspective, the diameter is 7 centimeter. Right. So how are we going to solve it? Okay. Yeah. Again, we need to find the arc length. So how do we go through? Since it's a half circle, you can just directly put 1 by 2 into 2 into 22 over 7. 22 over 7 into what was the radius? Yeah, 3.5. Since diameter is 7, the half of 7 is 3.5. And then you can go ahead and cut. Also do make sure, if you haven't calculated already, 3.5 times 1 and 3.5 times 2 is equal to 7, right? Cancel, become 11. So we are left with what? 11 centimeter. Okay. So there you have it. 11 centimeter is the arc length, right? Not the perimeter. We still did only the arc length. Then how do you get the perimeter? Right? How do you get the perimeter? Perimeter. As you know, it was an isosceles triangle. Therefore, two sides are equal, which means 4 plus 4 plus the arc length, that is 11, right? Therefore, the answer should be, what's it, plus 11. It is 29. Answer is 19 centimeter. Right? Make sure you write your centimeters. Don't forget. Okay. Right. So now we can go to the question number 2. A semicircular portion of diameter 7 centimeter has been cut out from a semicircular lamina of radius 7 centimeter and welded to the lamina again as shown in the figure. Okay. So what is our first question? Find the arc length of the sector of the circle of radius 7 centimeter. Right. Uh, so in this figure, you need to identify two parts. That is what we have one half a sector here, then another half a sector here. Then a big full half sector is given. So altogether we have three sectors, right? Altogether we have three sectors. Well, basically it's actually two sectors because even if you find the arc length of this sector, you still have the same answer for this one. They both are same sectors, right? So yeah, basically, like if you say theoretically, it is two sectors, right? So what does the question ask us to do? Find the arc length of the sector of the circle of radius 7 centimeter. Radius 7 centimeter means what? We are trying to find the sector of the. So we are trying to find the arc length of this big what? The big sector. And how do you do that one? So again, since it is a half sector, we can use half into 2 into 22 over 7 into what was the radius? 7. So then 7 cut 2 and 2 cut, right? And we are left with what? 22 centimeter. We are left with 22 centimeters the arc length. That's it. So the next part, find the arc length of the sector of the circle of diameter 7 centimeters, right? Second part, find the arc length of the sector of the circle of diameter 7 centimeter. So when they say diameter of 7 centimeter, which sector has a diameter of 7 centimeter? It's definitely the small one, right? Not the big one. The big one's diameter is actually 14 when they move together. But when they say diameter of 7 centimeter, it means what? The small circle. So that therefore the radius of it is what? 3.5. Again, half into 2 into 22/7 into radius is what? 3.5. And again, 3.5 times 3.5 times 2, 1, 1. So, yeah. So again, you're left with 11 centimeters the arc length. So like I said, there are two sectors are same. So if this one is 11 centimeter, that means this one is also 11 centimeter. And then what's the last question? Find the perimeter of the shaded region. So how do you find the perimeter of the shaded region? Just simply at the arc length. So what was the arc length we had? Right? Perimeter plus 22 plus 11 plus 11. So it's two small sectors and one big sector. So what will be our answer? It is 44 centimeter. Right? Make sure you write your centimeters. So the answer is 44 centimeter. Okay. Right. So then we move on to the third question. Third question, right? The figure illustrates how an equilateral triangle of side length 7 centimeter is drawn within a sector of a circle of radius, the length of a side of the triangle. So find the arc length of the sector of the circle. So we are told to find the arc length of this tiny arc length here. It's a tiny circle. Yeah. Okay. And we have been given a data that this is an equilateral triangle and each side is 7 centimeter. Therefore, we know that the diameter of that particular sector is also 7 centimeter. So let's find the arc length quickly. Again, half into 2 into 22/7 to radius 3.5 times 2 to 1 to 11 1 1. Why is all answers coming 11? Right, 11 centimeters. Okay. Yeah, so that sector's arc is 11 centimeters. Then we find the perimeter of the shaded region. So that's of course easy, right? So what is the perimeter of the shaded region? You have to add the arc length and the diameter. That is, what's the answer then? So 11 plus 7 is 18. Perimeter of that is 18, right? So let's go on to the next question. The figure shows two sectors of circle ABED and CDFB. If AB is 10.5, so where is AB? AB, yeah, AB is 10.5. Find the perimeter of the shaded region using the given data. Okay, so it's again so simple, nothing to worry about. Okay. So if we know this is the so this is AB is given 10.5, right? And we know this is a square. The outside is a square. In a square, opposite sides are all equal. I mean, basically all sides are equal. 10.5 AB. So then all the other sides also 10.5. So then what is our question? Find the perimeter of the shaded region, right? Shaded region. Therefore, what you have to do is, if you take in the perspective of DAB and then E, so then what you will get this sector, this part. See that? DAB then passing to E. So then it's basically a sector. So therefore, what will be our radius? Radius is 10.5, right? So since it's equal, it's inside a square. That means even if you just find for one sector, it's enough, because this side is also 10.5. Then this side will also be 10.5. Okay, it's using the same radius. So let's start finding for one. So now be aware that is a 90-degree sector. Therefore, if it's 90 degree, you need to use 1/4, 1/4. 2 into 22/7 into our radius is 10.5. Okay, so some kids don't know that you can actually cut this. It's easy, right? That 7 times 1 and 7 times 1.5 gives you 10.5. Okay? 7 times 1, 7 times 1.5 actually gives you 10.5. Then if you can cut this to 2 to 11, at the end we just have to multiply 11 and 1.5. 11 1.5, and we'll get our arc length. So what is the answer for 11 into 11.5? 11 into 1.5 into 1.5, and our answer is 16.5 centimeter. Okay, our answer is 16.5 centimeter. So if that, so now if the one sector area is 16.5, one arc length is 16.5, the other arc length is also 16.5. Henceforth, the perimeter of that shaded region, right? It is what? 16.5 times 2. Or you can add it, if you like. 2 5 is 10, 2 6 is 12, 13, 2 1 is 2, 3. The point comes down. So the answer is 33 centimeter. Okay. Yeah, so that was the perimeter of that shaded region. And then we come to the last one. The figure shows two sectors of circles of center A and radius AD and AR respectively. How much greater is the perimeter of the sector APQR than the perimeter of the shaded region? For most of my students, like I have been through situations where some students said they can't understand this question. I think it's because of how the second part of the question kind of brings confusion to them, because it asks what? It asks how much greater is the perimeter of the sector APQR. APQR, right? How much greater the perimeter of the sector APQR than the perimeter of the shaded region. So basically what you have to do is you have to get the perimeter of this shaded area, right? That means you have to get the arc length of the small sector, and then you have to get the arc length of the big sector, right? And then if you add this BP and the DR side, you will get the perimeter. I'm going to do that. So, I mean, what the question is asking you to do is find the difference, right? Basically, they're saying find the difference. Find the difference between the shaded regions perimeter and the big sectors perimeter. They just want to know the difference. How much greater is the perimeter of the sector, right? Again, they are asking the difference. So let me just write it down for you. Okay. So in order to get our perimeter for the shaded region, shall we do shaded region first? No, let's go for the big sector, right? Okay, I'm just going to put B sector. B sector means big sector, right? I'm doing for the big sector. So we have to find the arc length. How do you find the arc length? What's our angle? Angle in the middle is 45 over 360 times 2 into 22 over 7 into what's our radius? So radius is 3.5 plus 3.5, that is 7 centimeter. Okay. Okay. Now, so as our theta, we got 45 over 360. So if you do your divisions properly, this is actually 1 over 8. Okay. 1 over 8. Then 7 and 7 gets cut. 2, 1 and 2, 4. Then you can cut it again. 2, 2 and 2, 11. So we will get an answer such as 11 over 2. And it's we get an improper fraction, right? So what do we do? Shall we leave this improper? Now let's just convert it to decimal, right? So in decimal, what is it? I think it is 5.5. Yeah, 5.5 centimeter. Okay, so we found the arc length of the big sector. And then what is the perimeter now? Perimeter is 7 plus 7 plus 5.5. So you know 7 plus 7 is 14. Now we just need to find for 5.5. Sorry, 14, right? If you add 3.5, 3.577, that's 14 centimeter. And then we have to additionally add the 5.5, right? So the addition of 14 and 5.5 will give you the full perimeter of the big sector. So the answer would be 19.5 centimeter. 19.5 centimeter is the perimeter of the whole uh, big sector. Let's just keep that aside. Okay. Now we know big sector. B sector is 19.5. Now the shaded region. Now we have to find the shaded region's perimeter. How do we find the shaded region's perimeter? For that, we need to find the small sector's arc length. So yet again, it is 1 over 8 into 2 into 22 over 7 into the radius is what? 3.5. 3.5 times 1, 3.5 times 2. 2 and 2, 11, 2 and 1 is that's 4. So now we're getting again a fraction answer, that is 11 over 4. I think the decimal answer would be 2.8 maybe. Let me just check. I'm so close. So it is 2.75. 2.75 centimeter is the arc length of the small sector. Now, since we found that, we know BP is also 3.5 centimeter, right? Because it's a big arc, it's a big sector. So therefore, the radius is also equal to the other side. Therefore, BP is 3.5 centimeter. And I think we can get the perimeter of the shaded region then. So it is what? Now the perimeter of the shaded region would be, let me just the shaded region. So what? 8.75 plus 2.75 plus 3.5 plus 3.5, or you can just write 7 for short. And what was our big sectors? Oh no, did I forget? Oh no, this is not good. I forgot it. 5.5, the arc length of the big sector, right? So then if you add them all up, we get the perimeter as what? So let's calculate. 5.5 is, so we get the answer as 15.25. 15.25 centimeters. Okay. 15.25 centimeters is the shaded region. Shaded region. 15.5. Okay. Now that we got our two perimeters, right? We got the big sector and the small, sorry, the shaded region. So we are now going to solve the second part of the question. They asked you, sorry, let me read the question. How much greater is the perimeter? How much greater is the perimeter of the sector APQR, APQR, than the perimeter of the shaded region? So what do we have to do? We're going to have to subtract the big sector and the shaded region's perimeter. Therefore, it is 19.5 subtracted from 15.25. So if there is a second digit in the decimal side, you automatically put a 0 here. Therefore, here it's going to be 5. Here it's going to be 5. Here it is 2.9, right? Yep, there you go. So the answer is 4.25. The answer is 4.25. So this is the big difference, right? So this is the answer for that question. 4.25 is the answer. So I guess that is it. Miscellaneous exercise. I'm not going to do it, but I recommend if you all can do it. If you all did do you know, share your answers in the comment box, maybe, so you can help others. And I think we have completed our first chapter. Okay. Yes, it took me time to upload because in my end, I do have a lot of work and I couldn't find the time really. But I am trying my best to upload weekly, at least maybe one video per week. Yeah, I am trying, but let's hope so. Okay. So we have our next lesson is square root. Yeah, it's not a big deal. It's not a big deal at all. It's easy. And I guess I'll see you all in the next video where I explain square root.